So sharp, consider the sequence 2, 6, 18, 54. Right? Looking at this sequence, can you guys tell me what the next number is? Can you guys tell me what the next number is in the sequence? Come on. Can you guys tell me the next number? Anyone? The next one is 162. Yes. And after that, what do we have? 486. Proper stuff, and so on. So now, how did you see that the next two numbers are 162 and 186? Sorry, 486. So, yes, cause you? Yes, proper stuff. So she saw that between successive terms, we multiply the number 3. So that's how she got to these two answers. She just multiplied 3 to 54. She got 162 and so on. Okay, sharp. So now I said if you can't see the number by which they multiply at first glance, what do? You simply go, because clearly this is not an arithmetic sequence, right? They're not adding the same number. You can clearly see there's no way that okay, we've got a 4, they added a 2 to the, sorry, they added a 4 into the 2 to get a 6. So from them to move from 6 to 18, there's no way they added a 4. From 18 to 54, there's no way that they added a 4. So without even having to investigate too much, you can clearly see that this is not an arithmetic sequence. It is not a linear sequence. So that's why we just straight ahead opted or tested for a geometric sequence. So yeah, we saw that we multiplied 3 between successive terms. And I said that if you can't see with a naked eye, you can't see immediately, what you do is you're going to go the next number. 6 divided by the previous number 2 gives you 3. So this would then imply that they multiply the 2 by the 3 to get to the next number. Do the same 18. Next number divided by the previous number 6 gives you 3. Do the same for all of the other successive terms. You'll actually realize that they are multiplying by 3 between successive terms. Now, this type of sequence in which they multiply the same number or divide, if you like, same number between successive terms, or rather, yes, same number between successive terms is called the geometric sequence. We did this last week. Geometric sequence. And this number is what we call the constant ratio. The number they multiply by. Constant ratio. Any questions? Come on. No questions. All right. So now, since you guys understand, Lwandle, do you understand what a geometric sequence is, Lwandle? Proper stuff, proper stuff. So now, let us now compare this so-called geometric sequence to what we call the geometric series. What is the difference? The difference is that instead of you having columns in between successive terms, you still have it as a sequence basically, but it's got either pluses or minuses in between. So I want to rewrite the sequence above. I'm going to write it there. All right. So instead of it having columns, it will have pluses or minuses or combinations of pluses and minuses. But in this case, we have pluses. So this is what we call a geometric series. It is a series with a constant ratio. That's what it is. Happy? Good, 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 good. So now, yeah, so a question comes and says, in this gives you a sequence like that, a geometric sequence like that, and they ask you what is T1, what would you say? It is member number 1, it's 2. What is T5, for example? 1, 2, 3, 4, 5. It is member number 5. Okay, that's what that thing is. If they bring you a series like this in an exam, they ask you what is T1. It's just the first term. That's what it means. The number that is positioned first. That's what it means. Does not change regardless of whether you're working with a geometric series or geometric sequence. T3, it is still 18. Does not change. Now, what about S2? What is S2? S2 is the sum of the first two terms of either the series or pattern. Even if they give you this or that, S2 just means you're adding the first two members. So it's just S2 just means T1 plus T2. S3, um, S3 would just mean T1 plus T2 plus T3. All right? Yes, boss. Yes, boss. I'm listening. Um, okay, Lulama, please try again because I see that you're asking a question, but your network is cutting you. Can you just move a bit and ask the question? If you like, you can type. Waiting for Lulama to ask a question. I'm just gonna pause for just stay sharp. So, where was I? So I was just showing you that T1 would always mean member number one of a pattern of a series or a sequence. It does not change. T3 would just mean member number three of a series or sequence. Then S2 just means the sum of the first two terms, T1 plus T2. S3 means the sum of the first three terms, T1 plus T2 plus T3. Okay, so that's what that means. T4 would be the sum of the first four terms. All right. So now let's go ahead and find S2. S2 is just you just literally rewrite it as it appears there, right? Copy it as it appears. This gives you an 8. S3, copy as they appear. 2 plus 6 plus 18 equal to 26. All good, yeah? Sure, sure. Can you guys find me? Okay, you guys already know, I'm sure. S4 will be just the sum of the first four terms. Okay, I'm gonna pause here and ask you, allow you guys to ask questions.